Let us consider a green-colored cylinder filled with oxygen and a red-colored cylinder filled with acetylene. Since acetylene is a highly explosive gas, so we keep it at a lower pressure than oxygen. Now let us attach regulators to these cylinders to regulate the outflow of gas through them. Then connect a welding torch to these regulated cylinders by hoses, which are used to carry gases from the cylinders to the torch. We see that this welding torch consists of two control valves to control the flow of gas locally. On the tip of the welding torch, we also see an orifice to allow the gas flow out of it. Now let's open the acetylene valve and ignite the welding torch with the help of a striker, keeping the oxygen valve closed. Since no external oxygen is supplied, we see that acetylene burns with the help of oxygen present in the surrounding air from a sporadic flame. Now if we open the oxygen valve too, we see that the welding flame turns into a continuous beam. And when we supply equal amount of oxygen and acetylene, a neutral flame is obtained. Now let us use this welding torch to weld two similar metallic plates with each other. For this, we bring a filler rod of similar composition between the edges of the plates and heat them with the torch flame. We see that the flame melts the edges of the plates and the filler rod to form a homogeneous molten pool. We then remove the flame and the remaining filler rod and allow the plates to cool. On cooling, the plates get joined with each other. This process of joining two similar metals with the help of oxygen and acetylene gases is called oxyacetylene welding. Thus we can say that oxyacetylene welding is the process of joining two similar metals at high temperature attained by the combustion of acetylene in the presence of oxygen. Related terms are flame and its types. We know that oxyacetylene welding is the process of joining two similar metals at high temperature attained by the combustion of acetylene in the presence of oxygen. Just at the tip of the torch, we see that an inner cone is produced, where the primary combustion takes place. In the primary combustion, acetylene reacts with oxygen to form carbon monoxide and hydrogen. This reaction is exothermic and a lot of heat is produced. Hence the temperature of around 3050 to 3450 degrees Celsius is developed in this inner cone. As the product gases of the primary combustion, carbon monoxide and hydrogen, come out of the inner core, they react with each other in the presence of oxygen to form carbon dioxide and steam. This is known as the secondary combustion, where the amount of heat produced is less than that in the primary combustion. Hence we see an outer envelope is formed around the inner cone. The temperature in the outer envelope is around 1250 to 2100 degrees Celsius. Thus we can define oxyacetylene gas flame as the flame produced by the combustion of acetylene in the presence of oxygen to attain temperature of around 3000 degrees Celsius for welding and cutting metals. There are three main types of oxyacetylene flames used for the welding purposes: neutral flame, carburizing flame, and oxidizing flame. Now let's discuss each of these flame types one by one. Let's start with the neutral flame. When we supply an equal amount of oxygen and acetylene to the oxyacetylene torch, we see that a flame is produced. This flame is known as the neutral flame. The inner core of this flame is smooth and soft rounded and is whitish in color, while its outer envelope is bluish in color and not much luminous. This outer envelope protects the molten metal from oxidizing. Neutral flame is generally used to weld metals like mild steel, copper and stainless steel. Now let's move to the carburizing flame. When the amount of acetylene supplied is more than that of oxygen, a carburizing flame is produced. The inner core of this flame is sharp and whitish in color. Around the inner core, an immediate cone is produced, which is feather-shaped and reddish in color. The length of this feather-shaped intermediate cone depicts the excess amount of acetylene present in the flame. The outer envelope is bluish in color, similar to the neutral flame. Due to the excess acetylene present in the carburizing flame, some acetylene goes into the molten metal, which makes it hard and brittle. Hence, carburizing flame is generally used to weld hard metals like high carbon steel, cast iron, etc. Finally, let's discuss about the oxidizing flame. When the amount of oxygen supplied is more than that of acetylene, an oxidizing flame is produced. The inner cone of this flame is sharp and short and whitish in color. The inner core is surrounded by an outer envelope, which is bluish in color, but smaller and narrower than that in case of neutral and carburizing flames. When we use this flame for welding, a harsh sound is produced, and the excess oxygen forms an oxide layer on the molten metal. Oxidizing flame has the highest temperature levels among all oxyacetylene gas flames. Oxidizing flame is generally used to weld metals like brass. Related terms are